Assalamualaikum and a very good morning to my teachers and my fellow friends. Today I would like to share about motors. I am Muhammad A and this is my partner Muhammad Dani Haidar. Okay, first thing is introduction. Overview of AC motor. Squirrel cage induction motor. The most widely type. It has a simple construction and robust, making it ideal for most industrial applications. One rotor induction motor. This motor has winding on the rotor and it is used for applications that require high starting torque or variable speed. Advantage of induction motors: simple and rough design, low cost and easy to maintain, self-starting, wide range of application. Synchronous motor. In synchronous motors, the rotor is magnetized and rotates at the same speed as the rotating magnet. Field produced by the stator. This means the rotor always synchronized with the frequency of AC power supply. Synchronous motors are often used in applications where precise speed control is important. Advantage of synchronous motor: constant speed under varying loads, high efficiency, especially in large machines, can operate at leading power factor, used in power factor correction. The next, the story of the AC motor. The AC motor that is your plan right now has a long and story and going on the way that the Michael Faraday 1830 discovered that a tiny magnetic field can induce an electric current in a circuit. 58 years later, that discovery culminated in Nikola Tesla 188 patent for the first AC commutator free voltage induction motor. Next, content. Function of the AC motor. The function of an AC alternating current motor is to convert electrical energy to mechanical energy and operate by using alternating current to generate the rotating magnetic field which interacts with the rotor, the rotating part of the motor. This interaction causes the rotor to turn one perform mechanical work such as moving mechanical or application. Function of AC motor. Rotation. The AC motor rotation moves with this commonly used in industry equipment application and wheels. 2. Speed control. The speed of AC motor can be controlled by adjusting the frequency of the alternating current which change the speed of the rotating magnetic field. 3. Torque production. The motor generates torque to perform tasks like pumping, lifting, or driving mechanical loads. 4. Energy conversion. The motor converts electrical energy into mechanical energy to perform a wide
variety of mechanical tasks. Next. Picture of the part of the motor. Synchronous AC motor. Fan cover, fan bearing, gearbox, terminal box, starter winding, template, frame, rotor, shaft, and shape, regular, winding slider. Next.
The name of the part of AC motor and the function. AC motor consists of several key parts, each performing a specific function that enable the motor to operate efficiently. Below are the main part of an AC motor along with their function. First, starter function. The starter is the stationary part of the motor, which generates a rotating magnetic field when an AC supply is applied to it. This field interacts with the rotor to produce motion. Second, rotor function. The rotor is the rotating part of the motor. It is located inside the starter and is driven by the magnetic field generated by the starter. The rotor's motion is what produces mechanical work or output. Number 3, shaft function. The shaft is connected to the rotor and transmits the mechanical power generated by the rotor to the load. Example, a fan, pump, or conveyor belt. Number 4, bearings function. Bearings support the shaft and rotor, allowing them to rotate smoothly with minimal friction. Number 5, winding coils function. The starter has winding made of copper or aluminium, which are energized by the AC power supply. The current flowing through this winding generates a magnetic field that causes the rotor to rotate. Number 6, commutator. In some AC motor like universal motor function, in certain type of AC motors like universal motors, the commutator helps reverse the direction of current flow in the rotor windings, ensuring continuous rotation. However, in the modern AC motor, such as induction motors, the commutator is not present. Number 7, end balls or end shields function. These are protective covers at both ends of the motor, which house the bearing and help protect the internal component from dust, debris, and moisture. Number 8, cooling fan function. AC motors often have a fan mounted on the shaft to cool the motor and prevent overheating by circulating air over the motor's body. Number 9, insulation function. Insulation materials are used to electrically isolate the starter windings and rotor from each other, preventing circuits and ensuring safety and efficiency. Number 10, terminal box function. The terminal box is where the motor's electrical connections are made. It houses the terminal for the power supply and sometimes equips control circuits or protective device. Next.
Color of the motor. AC motor, like other types of electric motor, can have various color depending on the nature, purpose, and design. However, there are common color that basically appear in the construction and in the external compartment of AC motor. 1. Motor housing. Chassis. Gray, often used for industry and commercial motor unit. Is a neutral color that is it and wear black. Frequently used for smelly or accidentally water. Blue. Some manufacturers use blue often for branding, purpose, or specific product needs. Silver. When aluminium often used for high performance motor or used with aluminum casing. Next. This color motor. Next.
Texture of the AC motor. The texture of AC motor varies depending on the material used in their construction and the specific design of the motor. Here's an overview of the texture you might encounter in different parts of an AC motor. First, motor housing, casing. Smooth and glossy. Some motors, especially smaller or precision design ones, may have a smooth, glossy finish, particularly if the casing is made from molded plastic or aluminium. Second, rough or matte. Many industrial AC motors, particularly those used in heavy-duty application, have a rubber or matte texture. The housing is often made of cast iron or steel with a textured surface to help with heat dissipation and durability. Third one is texture or grip. Some motor housing, especially those made of aluminium, may have grip or fine texture. This design aids in heat dissipation by increasing the surface area. Motor shaft. Smooth. The motor shaft, usually made of steel, is typically smooth to the touch as it is designed to rotate freely within the bearings. The surface might be slightly polished for smooth operation. Machine or groove. Some shafts may have grooves or keyways for attachment purpose, such as for securing pulleys or gears. Three windings, starter or rotor, insulate and smooth. The copper winding, which are coated with an insulation material, often have a smooth and slightly shiny texture. The wire insulation is generally smooth and may feel slightly rubbery or plastic-like. Wire surface, copper or aluminium windings may have a slightly rough or rich texture, especially if the wire is not heavily coated. The four bearings, smooth and polished. Bearings are designed for smooth rotation, so they have a polished and often shiny texture. The bearing surface must be free from defects to ensure proper functions. Number 5, end bells, frames, smooth or slightly rough. The end bells which house of the bearings at the end of the motor may have a smooth texture or a slightly rough texture, depending on the material, cast iron, aluminium. Cooling fins for larger motors. Grip or fine. The texture of cooling fins often found the exterior of larger motors. Is typically ripped or solid. This design helps to improve the motor dissipation by increasing the surface area.
Material used to make the AC motor. AC motor are made for a variety of material as choose for this specific property that contribute to the motor efficiency, durability and performance. The key material include 1. Copper, used in welding, starter and rotor coil. Reason copper is as excellent conductor of electricity with that minimize energy loss and improve motor efficiency. 2. Iron or steel, used in starter core, rotor core and laminate steel. Reason iron or steel is used for its magnetic properties. The core material have contingent and guard the magnetic field, and the lamination produce energy loss due to eddy current. 3. Aluminium, used in rotor bar in some motor and casing. Reason aluminium is lighting and less expensive. The copper makes it a good choice of for some rotor design and for reducing the overall weight of the motor. Next, stay alone. Used in marine and housing. Reason stay alloy usually and decided to wear and cross-section, making that for supporting the rotating part of protecting the motor. 5. Insulating material. Used in insulation around welding. Result material like premise, resin or animal are used to insulate copper welding, reducing electrical short current and improving the motor performance. 136 permanent magnet in some AC motor. Used in rotor in permanent magnet AC motor. Reason high strength permanent magnet of the net of rare earth material like aluminum are used to generate the magnet field, using the net for extension. These material work together to ensure that AC motor can operate efficiently and reliability over a long period. Next,
measurement of the AC motors. When referring to the measurement size of an AC motor, you could be asking about the physical dimension, rating or standardized frame size that indicates the motor design, mounting and power handling capabilities. Here are some key measurements typically associated with the size of an AC motor. First, frame size. Definition. This is a standardized way of specifying the motor's overall dimension, primarily for mounting purpose. Example, a motor with a frame size of 66 or 180 correspond to certain dimension like mounting bolt, circuit diameter, shaft size, and motor length. Measurement. A frame size is usually identified by a number that refers to the motor's diameter and length in millimeters or inch, depending on the standard in use. For example, an NEMA 56 frame size typically has a mounting flange diameter of 6.6 inch. Next. Second, shaft size. Definition. The shaft size specifically the diameter of the shaft which is used to connect the motor to the load. Measurement. For example, 1 inch shaft diameter of a shaft with a keyway may be specified. Number 3, motor length. Definition. The total length of the motor from the end to end which can be critical when fitting the motor into an existing space. Number 3, measurement. Length varies depending on the frame size and design of the motor. Number 4, motor diameter or frame diameter. Definition. The motor's outer diameter typically the reference to the largest part of the AC motor housing or frame. Measurement. This is usually specified in millimeters or inch and is essential when determining the space required to fit the motor. Number 5 is weight. Definition. The weight of the motor is another important related measurement as it impacts installation and transport. Measurement. Weight is typically specified in kilograms or pounds. Number 6, rated power. Definition. While not a physical dimension, the rated power in horsepower or kilowatts or an insertion size is specifically of the motor indicating its capacity to handle load. Measurement power is rated based on the motor's ability to produce work, and this will correspond to its frame size and design. How to use the AC motor step by step.
Use an AC alternating current motor. Follow this basic step, ensuring you adhere to proper safety produce and consult the motor manual for specific instruction. 1. Understand the motor type. AC motor come into main type: induction motor, most common, and synchronous motor. Now please start your working with as the operation and ready can differ. 2. Power supply. Ensure you are using the correct voltage and current for the motor. Was AC motor designed for specific important rating. Example: 110 volt, 220 volt, 380 volt. Make sure the power supply matching the specification of the motor. Example: single phase or three phase. Next, 3. Motor connection. Wiring. For single phase motor, generally have the wire for power supply along with ground wire. For three-phase motor, you have 3 power supply wire to ground. Connect the motor to the electrical panel on the operator starter depend on the application. 4. Motor starter and protector. For large motor or industrial setting, use a motor starting protector and control the flow of electricity and protect the motor from damage. Example: overload protection. 5. Safety check. Before turn on the motor, check the following: the motor is grounded, all connections are sure, the motor is properly not, there is no obstruction. Ensure the power supply is on before making a connection. 6. Start the motor. Switch on the power and then start the motor using the motor starter, the on-off switch. In some cases, you only has speed control, frequency drive, brake handle adjusting the motor speed. If the motor uses a capacitor, ensure that the capacitor is connected and functioning. Next, 7. Motor operation. 1. The motor starter is begin cleaning at the red stick. Check for loose overhead or vibration. Please start in problem. 8. Stop the motor. To stop the motor with off the power supply. For safety, always turn off the main power secure before performing any maintenance or adjustment. 9. Maintenance and troubleshooting. Today, to inspect the motor for dust, wear and wear. Ensure the bearing lubricated if needed. motor is static or running properly, troubleshoot based common issue like power supply problem, damage wiring or overload. Safety considered. Always follow electric safety standard and procedures. Ensure the power is off when making adjustment or connection. If you are not sure or desperate, use the best consult professional electrician or technician to avoid condition.
2.9 Maintenance requirement of AC motor. Proper maintenance is crucial for ensuring the longevity, reliability and efficiency of AC motors. Regular maintenance helps prevent unexpected failures, reduce downtime and improve overall performance. Below are the key maintenance requirements and practice for keeping AC motors in working connection. First, regular inspection, visual inspection. Number 2, cleaning, keep the motor clean. Number 3, lubrication, bearings and moving parts. Number 4, monitor the motor performance, temperature monitoring. Number 5, check electrical connection, check for faults. Number 6, alignment and balancing, check for motor alignment. Number 3 is conclusion. Advantages and disadvantages of the advantage of AC motor: simplicity and reliability. AC motors are relatively simple in design with better components that can be out, making that highly reliable. They have no push induction motor. This reduces the need for maintenance. 2. Cost efficiency. AC motor generally is expensive to manufacture and maintain compared to DC motor because the handleable part the recruit research. The absence of good always reduce wear and tear, making them more convenient. Wide range of application. AC motor can be used for a wide range of application, from small household application to large industry application. They are commonly used in fan, pump, compressor, conveyor, heat and electric units. 4. Especially at high speed. AC motors are efficient when operating at high speed, making that way for application where continuous motion is required, like in industry equipment. Next. Disadvantage of AC motors. First, complex speed control for synchronous motor. While induction motor have simple speed control mechanism, synchronous motor require more complex and costly equipment for speed regulation, making them less versatile for some applications. Synchronous motor also require an external power source for the rotor's magnetic field, which increases complexity, size and weight. AC motor, especially large industrial one, tend to be bulkier and heavier compared to DC motors of similar power rating, which can make installation more challenging. The larger size can also contribute to higher transport costs. Number 3, low starting torque for induction motor. Induction motors which are among the most common type of AC motors, generally have lower starting torque compared to DC motors. This can make them unstable and suitable for applications that require high starting torque, such as heavy machinery. Additional equipment like a soft starter or inverter might be needed to address these issues. Number 4, power loss for induction motors. AC motors, particularly induction motors, can experience power loss in the form of heat due to the resistance in the windings and core losses. These losses can reduce efficiency, especially at higher power ratings. The safety on operating AC motors. Safety when operating AC motors. Operating AC motors safely is crucial to prevent accidents, injuries, or damage to equipment. AC motors are used in various applications, from household appliances to large industrial machinery, and each type of environment presents its own set of hazards. Below are essential safety guidelines to follow when operating AC motors. First, ensure proper installation and setup. Qualified personnel. Only qualified and trained personnel should install, operate, or perform maintenance on AC motors. Correct motor ratings. Ensure the AC motors is correctly rated for the application in terms of voltage, current, power, and speed. Using a motor with incorrect ratings can lead to malfunction and overheating or even failure. Securing mounting. To ensure that the motor is securely mounted to avoid vibration or movement that could cause mechanical failure or injury. Proper wiring. Ensure all wiring is proper insulated and connected. Use appropriate wire size to handle the motor's power rating. Number 2, power supply and electrical safety. Hearing protection. In environments where motors produce high level of noise, such as industrial setting, wear hearing protection to prevent hearing damage. Non-conductive wear. Wear rubber shoes or boots to prevent electrical shock when working on or near the motor. Number 4, motor operating safety. Do not block ventilation. Ensure that the motor's ventilation system is clear of obstruction. Blocking ventilation can cause the motor to overheat and potentially fail. Monitor motor overheating. Overheating is one of the most common causes of motor failure. Ensure the motor has adequate cooling and that temperature limits are not exceeded. Install temperature sensors or thermostat when necessary. Check for abnormal noise or vibration. Unusual sound or vibration can indicate mechanical problem. If you detect any, stop the motor immediately and investigate the cause. Avoid overloading. Ensure that the motor is not operating beyond its rate capacity. Overloading can cause overheating and eventual damage to the motor. 5. Prevent maintenance. Regular inspection. Conduct regular inspection to check for signs of wear, damage, or malfunction. Look for issues such as thread wiring, loose connection, and sign of overheating. Lubrication. Regularly lubricate motor bearings and other moving parts to reduce frictions and prevent wear. Follow the manufacturer's guideline for the type and frequency lubricant. Cleaning. Keep the motor and surrounding area clean and free from dust, debris, and other contaminants that could affect motor performance and lead to overheating. Number 6. Emergency producers. No emergency shutdown producer. In case of an emergency, ensure all operators are familiar with the emergency shutdown producers for the motor and the entire system. This may involve cutting off power to the motor or activating an emergency stop button. Fire safety. AC motors, especially large one, can overheat and cause fire. Ensure that fire extinguishers are readily available and that personnel are trained in their use. In case of a fire, do not attempt to fight if it involves electrical component. Use a CO2 fire extinguisher or turn off the power supply first. Okay, this is our reference. Thank you for listening. Any question?
Question to Mr. Alam. How the motor function?
An AC motor is an electrical machine that converts electrical energy into the mechanical energy. Based on the interaction between the magnetic field created by the current flowing through the coils and the magnetic field of the starter or rotor.
Second one. What things can motor do?
An AC motor can perform a wide variety of tasks and is used in numerous applications across different industry growth its facility, efficiency and reliability. Here are some of the things an AC motor can do. 1. Drive industry machine. 2. Power household application. 3. Fan and blowing operation.
I have a question. Can motor use at outdoor?
Yes, AC motor can be used outdoor, but the suitably depends on the environment conditions and whether the motor is specifically designed for outdoor use. Thank you.